there! In this video, we will start to learn standard programming languages. Until now, we have used ladder logic diagrams to write our programs. This language is similar to the function block diagram. In this video, we are going to rewrite the project which was done and tested in the previous video to learn the FBD language. Then we will do simple projects to learn other standard languages as well. Let's start the video. As I mentioned earlier, I want to rewrite this project which was used to control two water tank systems in the previous video. Remember that I defined the two function and function block and I used them inside the main POU to control the two tanks. First, let's rewrite the program inside the function block. As you can see, its language is ladder diagram. Now let me create a new function block to write this program using the FBD language instead. Well, the first part of my program performs AND logic between these two variables. So let's find and use the AND logic. Now let's determine the inputs of the inserted AND logic. Note that based on the program, I need to detect the rising edges of the signal received from the fill push button. The rising trigger instruction can be used after the fill variable to detect the rising edges, and also I can right-click on the first input and use the edge detection item to detect rising or falling edges. Now let's continue and determine the next input. Note that I need the inverse state of the discharge valve. So I right-click on the second input to use the negation option. Finally, the output of the inserted pulse timer should be used to turn on the fill valve. As you can see, ladder and FBD languages and also their instructions on the right list are similar together. Their main difference is this line, which is usually used to enable instructions in a ladder language. Let's continue. I need a similar program to turn on the discharge valve. So let's copy and use the first network. Alright, I rewrite this program in a new function block using the FBD language. Let's continue with this function fctimer. This is its program in ladder language. Now let me create another function to rewrite it using the FBD language. Alright, to write this program, I need to find and use the subtraction, conversion, and division instructions in the FBD language. Note that although I am using the variables which were used inside the previous function, they aren't equal, because each variable belongs to a distinct function. Pay attention to their full names to understand this point. Since I am just rewriting the first function, let's copy all variables on the first function and paste them inside the declaration section of the new function. Now let's continue to rewrite the function using the FBD language. As you can see, these two programs that I wrote them in FBD and the ladder languages are similar together, except for this line, which is usually used to enable instruction in ladder language. Note that I don't have this line inside the second function, and the result of each instruction is sent to the next one directly. So these intermediate variables related to the first function were not used, and I can delete them. Alright, now that I added these two function and function block to the project, let's take a look at the main POU. As I mentioned in the previous video, it can be divided into two similar parts. So let's create a new POU and rewrite the second part in the FBD language. Remember from the previous video, the main program uses these two function and function block to control the water tanks. This part of the program controls the second water tank. Let's delete and rewrite it inside a new POU. I can use either of these function blocks to control the fill and discharge of the valves. Let's use the newer function block, which I rewrote it in the FBD language. Similarly, I can use either of these functions to convert the fill and discharge time to an integer number. I prefer to use this one, which is in the FBD language. This POU controls the second tank and this one controls the first one. So let me change their name. Now let's compile my project to ensure there isn't any error. Here is an important point. Although there are 6 program organization units, only 3 of them are going to be executed, because my controller is going to start its work from the first network of this POU, which calls these 2 functions. In consequence, only these 3 program organization units are going to be executed, which are related to the first tank. Now let's add this POU to control the second tank, which it uses these 2 functions. Let's compile the project. Okay, I am done with writing the programming steps. Now, a part of the program controls the first tank and the other part in FBD language is going to control the second tank. We can use the simulation option to test the project. I prefer to use factory I/O for the simulation. First, I determine which variables should be shared with factory I/O. Note that the initial project has been changed a little, and now this message means there are 5 variables which don't have any effect during the program execution. Naturally, I won't need to share them with factory I/O. So let me click on Remove to unselect them. Now, instead of selecting these 5 variables that are shared with factory I/O in the previous video, I need to select these 5 variables of the new program organization unit. Let's run the CODESYS control win v3. Well, the next step is downloading the project to the controller. The next step is defining some tags inside the KEP server EX software for connecting the program's variables to the equipment inside the factory I/O. Note that in this project, the selected variables belong to the 2 program organization units, Tank 1 and Tank 2. As you can see, I have modified these addresses and also checked whether the connection quality is good or not. Now let's launch Factory.io with the 2 water tanks that I designed in the previous video. Let's connect my program variables to the inserted equipment inside Factory.io via the created tags inside the OPC server. Let's test the 2 water tanks with the new program. As you can see, the first tank works correctly, but the second one doesn't. When I press its green or red push button, both fill and discharge valves get open. Note that I explained this problem in the previous video. Let's launch CODESYS and run the program related to the second tank. As you can see, these 2 timers are using the same variable. Let's change one of them and then download and test the new program. Well, the left water tank is working without any problem. In this video, I used the project which I explained in the previous video to learn about the FBD language. Now, I am going to explain a structured text language briefly using the help window. After that, I shall start a practical project using Factory.io. During the project, I will explain and use a global variable list for the first time. I will explain the CFC and the SFC languages later. Now let's start by testing the final version of my project. On the right side, you can see a buffer station, and on the left side, there is the final program. The whole program includes 3 program organization units. The main task of the first POU, whose name is manual auto, is calling manual or auto programs according to the state of the selector. Right now, the manual mode is selected. So let's open the second POU, whose name is manual. Here is a simple program to turn on the 2 belt conveyors with these push buttons. Note that 3 sensors have been installed at the beginning, middle, and end of the box moving line. The last sensor is used to count all of the